Good morning, everyone. Welcome and thank you for being here today. My name is Aniq and I'm excited to present our mini project on tomato leaf disease classification. This project is a collaborative effort aimed at leveraging the power of artificial intelligence to address a significant challenge in agriculture. Agriculture, as a cornerstone of our global food supply, constantly faces the threat of widespread plant disease that can devastate crops. To illustrate this, we have chosen to focus on tomato plants, which are particularly vulnerable to various diseases. Specifically, we will examine three common diseases affecting tomato leaf, which is bacterial spot, leaf mold, and spider mites. Our primary objective with this project is to develop a reliable and efficient classification model that can accurately identify these diseases, thereby supporting agricultural growth and sustainability. To achieve this, we have chosen to employ a deep learning technique known as convolutional neural networks, CNNs, which are particularly well suited for image classification tasks. Here's a brief overview of what we will cover in today's presentations, which is problem statement and motivation. We will start by discussing the importance of early and accurate disease detection in agriculture and why we choose tomato leaf diseases as our focus, dataset and tools. Next, we will outline our data source and the tools we use. Our dataset was sourced from Kaggle, and we utilize libraries such as TensorFlow and Keras for model development. Model development, we will dive into the architecture of our CNN model, the training process, and the steps we took to ensure its accuracy and efficiency. Result and evaluation. We will present the result of our classification model, including its performance metric and potential movement, implication, and future work. Finally, we will discuss the practical application of our project in real-world agriculture and possible future direction for enhancing our model. By the end of this presentation, we hope to demonstrate how deep learning can be transformative tool in combating plant diseases and promoting agricultural resilience. Our project employs a convolutional neural network, CNN, to classify tomato leaf diseases. The CNN model processes input image through a series of well-defined steps, which is adjusting the image size. The first step involves resizing the image to a standard size and rescaling them. This ensures that all images are of the same dimensions and are properly scaled for the model to process. Feature extraction. Once the images are resized, the CNN extracts relevant features from the image. This involves detecting age, textures, and patterns that are indicative of different types of diseases. Dimension reduction. To manage the complexity and computational load, we apply max pooling. This step reduces the dimensionality of the feature maps, retaining the most important information while discarding less significant data. Probability generation. Finally, the model uses softmax activation to generate the probability for each disease class. This activation function outputs a probability distribution across different classes, helping in the accurate classification of the disease. Our team has chosen to implement this method for its exceptional accuracy based on our specific criteria. We selected it because it consistently achieves the highest success rate in accurately recognizing and categorizing image according to our needs. This approach not only enhances our efficiency, but also ensures relevant outputs that align perfectly with our objective. By adopting this method, we aim to streamline our workflow and consistently deliver high quality and precise results. The decision to use a CNN was driven by several factors, which is accuracy. CNNs are renowned for their ability to accurately identify and classify images, making them ideal for our project's requirements. Efficiency. The steps involved in the CNN architecture, such as features extraction and dimension reduction, optimize the processing time and computational resources needed. Reliability. By leveraging the power of CNNs, we ensure that the results are reliable and consistent, which is crucial for practical application in agriculture. In summary, The CNN model architecture was chosen because it meets our criteria for accuracy, efficiency, and reliability, ensuring that our project delivers high quality and precise results consistently. After implementing a convolutional neural network (CNN) to classify tomato leaf diseases, we achieved notable results. The CNN architecture, comprising convolutional layers for features extraction, max fooling, four-dimensionality reduction, and fully connected layers for classification, utilize softmax activation to provide a probability distribution across three disease classes, using a dataset of 3,000 images to 2,100 for training and 900 for testing. We ensure balanced representation of bacterial sport, leaf mold, and spider mites. Pre-processing and data augmentation were applied to enhance performance and generalization. The model attained a high training accuracy of 95.71% with an error rate of 4.29% and a testing accuracy of 95% with an error rate of 3.78%. Recall and precision were 90% for bacterial sport and 85% for both leaf mold and spider mites, underscoring the model's effectiveness and reliability in accurately classifying tomato leaf diseases.
Like to demonstrate our apps. Okay, first thing is we type CMD to open the command prompt, and then after the command prompt is open, we type in this code. Okay, this is a code to create the virtual workspace for our app. Now that the virtual space is already created, and then now we need to activate the workspace. Okay, this is the code to activate the workspace. Okay, now we in the virtual workspace. And now first thing first, we need to install several libraries to make the app works. Okay, now I'm installing. Now we're done installing all the libraries for the app to work. We can now run the application. So this is the code. Okay, so now the application is running. So now we have finished training and testing the model. So this graph shows the training and testing accuracy and the training and testing loss. Okay, so now we can actually see the test accuracy is 96.22%, and the accuracy is 0.9571 and the loss is 0.1577, and the learning rate is 2.000 E and 04. So this is our demo. Thank you.